We have this.
Okay, you can turn to page 19 in your packet 5. We'll work on a couple of 2021 FRQs. Also, you guys picked up a handout as well. I decided that I typed up my FRQ predictions. That's more orderly, and then so hopefully that will be a starting point in terms of what to expect, because what you see on the board there, I mean, that's going to constitute probably like 90% of your FRQ test. It's just the order may be different, but these are the concepts that they want to test you over. But the order may be different. The subcategories may be under different problems, but those are the things you're looking for on your as you work through these FRQs. And also on the back of that handout, I also just had some test suggestions and advice. And I double checked with Miss Montreal, and she let me know that AB exam will be in the main gym, and then BC exam will be in the aux gym. I think last year it was aux gym and Q, but I think there's more BC students this year, so I think we'll be in the aux gym for May 12th test. Okay, so both 19 and 20, these are problems 5 and 6 on the BC 2021 FRQ. They're both non-calculator, so we want to work through this without a calculator. Go ahead and read the problem, try the problem, and I will go through each of the solution steps in about 5 or so minutes. Oh, sure. Thank you. Yeah.
Thank you. Wait, is ln of 1 0?
That's right. Dash log 1 is 0. Okay, so we gather enough information to be able to build our Taylor polynomial. Degree 2. So there's our formula for our Taylor polynomial. And we're going to gather our f of 1, gather our f prime of 1, which is coming from dy dx, gather our f double prime of 1, which is given to us, and then we just put it into that numerator portion of each of our polynomial terms. So f of 1 plus f prime of 1, x minus 1, f double prime of 1 over 2 factorial, x minus 1 squared. Go ahead and make your substitutions with the values that you know. Clean up your degree 2 Taylor polynomial, and then use that Taylor polynomial to make your approximation. F of 2 is approximately 6. Part B, Euler's method. Create your table, find your delta x. Delta x is b minus a over n. Just be aware that sometimes delta x could end up being negative. If it's negative, we need to make sure we include that in our as we step through our formula process. But in this case, delta x is positive, but it's possible that delta x can be negative if we're going backwards. Yeah, this is a bit of a pain without a calculator. So just to, which means that, you want to try your hardest just to not spend a whole lot of time trying to clean up, right? All you can do is represent the solution in some form, but you don't want to stress out about cleaning up any of your terms. As long as numerically it's equivalent to a simpler solution, then leave your answer in unsimplified form. Yeah, typically Euler's method is calculator, but it can be done without a calculator. Just Part C, solving a differential equation. This does feel like like an AB kind of a content, but the reason why it's here is because the integral process is going to require a little bit of integration by parts in order to get through to our solution. So that's why part C is a BC type of a problem. Any questions with part B? Does anybody still need to look at part B? I'll zoom in part C in a little bit.
What was like the term you used where it's like you can figure out which one comes first or which one's after G?
Oh yeah. Yeah, we really don't do anything with I. It's just logs, algebraic, trig, and exponential. And the way that we know something could involve integration by parts is when you have integral of the product of two different families of functions. Of course, we should always try U substitution first, but if we see that U substitution gets us down a dead end, then integration by parts could be a next potential option. I know we all prefer doing tab method, but we can only do tab method if you're doing algebraic and trig or algebraic and exponential. If logs is involved, you're kind of forced into this formula. So our f is natural log of x. Our g prime is x. From natural log of x, we find the derivative. From g prime, we take the antiderivative. And then we put it back into this right side there, f times g minus integral of f prime g. The annoying thing here is that after you put it back in here, you have to go through another process to get that resolved. But typically, this should be an easier problem now. It should just be power rule usually to get down to your answer. And then once you have it all cleaned up, then you can do your antiderivative with a plus c. And then you can go through the rest of your process, trying to solve for y, trying to solve for c, and then trying to clean up your equation from a general to a specific. Any questions with page 19? Okay, let's go to page 20. This is number 6 on the BC FRQ, which we always know that's going to be an infinite series problem when if it's a number 6 on the BC FRQ. So try that. Notes the 3 conditions for integral test: positive, continuous, decreasing.
You have to put the 0 to infinity, or you're saying positive continuous decrease. Like the statement at the top.
Yeah, we should include that that final statement 0 to infinity. Yeah. Just to be safe. I don't know. Yeah, I don't know if they'll pick off points, but I think that's the thing to do.
We have to put the bottom statement because the integral.
That's technically the reason that we know that the series will converge, because if the integral converges, then the series will also converge.
Okay.
So as far as whether they will take off a point or not, I don't know, but that should be the safer thing to write down, right?
Do you want usages?
Yeah, just indicate, show this for me and then I may take off a point. Yeah, thank you.
For these, how did you get from like the middle part to two?
Right, so for part B, we know the negative has no impact is the absolute value. And if I'm taking the limit as n approaches infinity, I'm kind of doing, like horizontal asymptotes, which is, comparing my degrees. And my degrees are kind of the same, so I just take the ratio of the coefficients, which is 2/1, which is 2. Because e to the n is the higher power, so the 3 will just go away. Now, this problem has good practice with these tests for convergence that we haven't had as much practice with recently because we've been dealing mainly with ratio tests or geometric series or piece series. We haven't done as much integral tests or comparison tests, so it's good that we're getting that practice here. So again, the way that we know that this series converges absolutely is because if we strip away the alternator, we'll have 1/2 e to the n plus 3, which we know converges because comparison with 1/e to the n is safe. We're able to show that these both converge. So if something can converge without the alternator's help, then we call that a absolute convergence. But if something converges, but if for some reason you took away the alternator and all of a sudden it diverges, then we call that a series that converges. Conditionally, conditionally. So sometimes students feel like, wait, conditional convergence, that means it doesn't converge. Yes, it does. It converges, but the reason that the word conditional is there is because if for some reason we're to take away the alternator and it turns back to diverging, then we call that a series that's conditionally converges. But both absolute and conditional convergence, they both converge for that series. Any questions with A or B? Part C, ratio test.
Okay.
Mm-hmm.
In the ratio test, why do you change the alternator to X? Like the -1 then?
Oh, yeah. So I just I completely removed the alternator because I knew the absolute value was just going to wipe it away. So I just didn't include it. But if you put it in there, it's fine. I just knew that it wasn't going to be a factor, so I removed it. after we clean everything up using ratio test. Remember, ratio test is a sub n plus 1 divided by a sub n. We get absolute value of x is less than e. So that's basically in the form of x minus c is less than r. We know c is the center. We know r is the radius. So center is 0, radius is e. So they're only asking us for the radius convergence. So all we need to provide is radius is e. Don't have to specify interval. Yeah, so just make sure that when you read a problem that you're providing the information that they're asking for. Sometimes you may provide too much information, right? You may think, oh, I'm going to do interval convergence. It's more work to get there, but you may not get full credit if they're only asking you for radius of convergence. Part D, they tell us to use the alternating series error bound. So we know we're looking at the first unused term to estimate the approx or the accuracy of our approximation. Now you may be thinking, oh, first two terms, so therefore it must be when n is equal to 3. But careful, that could be the case for some series, but this one starts at 0. So n equals 0 is the first term, n equals 1 is the second term. We want to use n equals n equals 2 to represent that third and first unused term. So we want to put 2 there to give it, that's the first unused term when n is 2, not when n is equal to 3. But it really depends, right? Look at your series. If it starts at 1, then yes, then you will want to use n equals 3. But because we're starting at 0, then the third term is actually when n is equal to 2. And this is something you should never have to guess. You know, they will always tell you where the series starts. So use their definition to build your to build each term of your series. Okay, so today, if you're able to make progress with the rest of 2021 FRQs, the suggested homework is to complete your 2021 FRQs. And then tomorrow, we'll look at 2018 and 2019 FRQs. All right, come with your phones. Yeah. Okay, thank you. I come with your phones.
Here, like, cancel, I get how you cancel out the accent, but then how do you cancel out these when there's like a +3 on both of them? Like, aren't you not supposed to do that?
Yeah, let me show you what I'm actually doing. I'm still comparing degrees. I just didn't quite show it to that extent. So you have questions about this part, right? So what if I wrote it this way? 2e to the n plus 3 over 2e e to the n plus 3. So the degree is really e to the n. So they're matching in degree. So I'm just pulling the ratio of the coefficients. And I'm just looking at, I'm ignoring the 3 because I know that this is like determining my roads.
Okay.
So it's like,
Comparison.
yeah, it's like 3x over 3 times 2 x squared. And my degrees are the same. I'm just pulling whatever's in front. Yeah, limit comparison test. So you first identify a series, a comparison partner, and we realize in part A that this converges. And so we use this and our we know that these are basically the same family, so we can divide them. It doesn't matter which order you divide them. As long as you divide them and show that you get a positive real number, then you know that these two must share the same, either converging or divergent behavior.
This great interest. He's really, I haven't seen a lot of major.
Mr. Doug, would you say the homework is?
Yeah, homework, you're just gonna work through the 2021 FRQs.
And that's just what, it's not just 19 and 20, right? There's other ones.
Yeah, there's like, every year there's 6 FRQs.
Okay, so.
Yeah, so I'll send out the page numbers this afternoon.
Might as well get some watch that.
This is or I guess sleep, I guess. Sleep really bad. Yes.
Yeah, I won't see our video.
No, I'm accept that.
Usually next time. Oh, you're not gonna do it. Or, I get that. What's up? Thanks for sincerely. I was gonna.
15 point.
It's good to I won't have one.
No, I'm gonna go try it. Really? I didn't know anything of the first one. That one.
All right, next time.
Is it one of the kids important? It's like. It's like.
These two, maybe like.
Oh, yeah, I don't.
No, we actually need to do this, it's like fun, that, like,
Well, we can't do this.
no, you need to be going on every day, you need to be going every day, and then just like this one, yeah, pops up seriously. They sell all these things, it is. They're a Coke, you need to buy them at custom.
Yeah.
You can actually.
That's why if I see him, I should just,
Yes.
if you see it, what do you?
Pop one, yeah. Just, no, on the, if you see one, tell me, hide it in like, with some, behind like some toiletry and on the.